Okay, sorry guys. I'm not used to recording in front of the camera. It's really weird to record with my face, you know? Used to be more like this. But now you can see me. So I'm sure most of you, unless if you're physics people or science people at all, have probably heard of the neutrinos going faster than light. It even made the regular newspaper, which is something that particle physics really often doesn't do. If you're just a normal person, you're probably looking for a bit more information. You know, you weren't happy with the short thing that got put at the bottom of your newspaper in one sentence: neutrinos travel faster than light. Here's a bit more details. They haven't released the full data yet on CERN. CERN is the European Organization for Nuclear Physics. They have the OPERA laboratory that actually sends the beam. So the way this experiment works, let me give you some background here, is that there's a laboratory here called OPERA, O-P-E-R-A, I think it is, which stands for something, I don't know what it is, and it's like over here. And then over here, 730 kilometers away, you have Gran Sasso Laboratory. And what they do is they shoot a beam of neutrinos, which are particles, they're leptons, so they're like electrons or muons, but they have very little mass and they go very, very quickly. You know, they, very difficult to detect them, and they're shot out by the sun. They're products, sometimes products of beta decay, and are subject to the weak force, I'm pretty sure. I'm not sure of any other forces, but I know at least the weak force. And what they do is they're trying to see, they think that neutrinos might change, oscillate from one type to another, from muon to tau, and or electron to muon neutrino oscillation, or electron to tau, or whatever. So this experiment was designed to see that. Now, they've seen something that they really didn't expect at all, which is they saw a neutrino going faster than light, essentially. You know, if they had sent a laser, this 730 kilometer line, these neutrinos would have arrived before the light, which, in case you didn't know, nothing is supposed to be able to travel faster than light. Nothing is supposed to go faster than light. So, you know, kind of a bit of, this is battling right here, the famous E equals mc squared is where this speed limit of light, you know, comes from. And so it's directly at odds with the most famous equation ever, E equals mc squared. So, you know, we'll see who wins, Einstein or CERN. But anyways, so, you know, now that you've got the background on how this experiment works, using 15,000 individual neutrino events, they have calculated that CERN and Gran Sasso, I'm not sure who runs Gran Sasso, but the CERN that runs OPERA and Gran Sasso have calculated that over 15,000 individual neutrino events, the neutrinos have traveled 20 parts per million above the speed of light in a vacuum, which is supposed to be like the cosmic speed limit, if you will. So they measure this 730 kilometer path, straight path that the neutrinos travel, accurate to 20 centimeters, which accounts for almost no time difference. 20 centimeters is very, extremely accurate over 730 kilometers. It's also, they've calculated the time down to an interval of plus or minus 10 nanoseconds. Now, these two measurements are not enough to put the error region, basically, if this is your error region here, and then, you know, your ideal measurement is somewhere in the middle between this error region, and then this is light, your error region doesn't quite match up with light, as in no part of the error region overlaps slower than light, or at the same speed of light, meaning these errors cannot be the cause of the problem. There has to be either some other error, or they found it, because the error of 20 centimeters and 10 nanoseconds are not enough to account for the extra speed. So, you know, what OPERA's done is they've taken these results, they said, well, this doesn't really make much sense, you know, I mean, they've done months of data taking to, you know, see that these results are true, and they have not found any statistical errors or problems with their experiment or problems with their math that have suggested that they did something wrong. Basically, they found that, yes, their neutrinos were in fact traveling faster than light by about 60 nanoseconds, I think. Not much, but that's still faster than light, which is more than you can say. And so, basically what they've done is, this doesn't make any sense, so at a CERN press conference, or an online thing or something. They basically invited the entire world to, prove them wrong. They didn't say prove us wrong, they just said check our results. So there's plenty of other neutrino laboratories. There's one in Japan, any other particle accelerators. The LHC probably has something to do with this. I know it can produce neutrinos, so maybe if the LHC produces a neutrino, it will study it. But any laboratories that are meant to send neutrinos from A to B, they can cross-check CERN. So they basically said, check us, and if all these checks come back positive, in 1 year or two, E equals mc squared may no longer be true. In fact, the speed of light may no longer be the cosmic speed limit. And then imagine how fast your internet connection would be if something arrived before it was sent, which would be pretty cool. Say, you got your internet at faster than the speed of light, you'd be like, your neighbor has FiOS, you'd be like, sucker, my internet's faster than the speed of light, and yours is only the speed of light. So, and science would just go haywire after that, because we'd have to redo everything, because, up until this point, E equals mc squared has been true, which is, So that's all the information I can find. They've, to summarize it, the errors, of 20 centimeters over the 730 kilometer path, and 10 nanoseconds from sent to receive time are not enough to account for this. So the error region doesn't overlap the region where they would expect the results to be, as in less than the speed of light. They've used over 15,000 events. They've spent months of cross-checking all their work to make sure that this is not a statistical error, and they've said it's not, so they've opened it up to scrutiny from everybody else. So, these neutrinos, as far as Opera can tell, and CERN can tell, and Gran Sasso can tell, and everybody else in the world can tell, are indeed traveling 20 parts per million faster than the speed of light in a vacuum. So, if you have a neutrino laboratory in your basement, which would be pretty awesome, I really would love to see your basement, please make a video of it, and invite me to your basement. It's kind of creepy. But, see if you can get your neutrinos to travel faster than light. Good luck. Took us almost 100 years to get something to go faster than the speed of light since E equals mc squared was made. So, thanks for watching. Bye.